The shortest side of a triangle has length 14. The other sides have lengths x plus 1 and x plus 3. Find the value of x that would make the triangle a right triangle and give the length of each side. So see what you can do with that. Draw a picture and make sure you use someone's special theorem. Maybe his name might be Pythagoras. So I expect that by now you've drawn a right triangle. The shortest side has a length of 14. The other sides have lengths x plus 1 and x plus 3. We're trying to make it a right triangle, so I went ahead and put the right angle there because that's our desired result. Did you put the x plus 3 and the x plus 1 in the same place as I did? We know x is not going to be negative, so we know that x plus 3 will either way, whether it's negative or positive, x plus 3 is going to be greater than x plus 1, so we're going to put x plus 3 on the hypotenuse and x plus 1 on the leg. Okay? Girls and boys soccer team will compete more about that tomorrow. Here we go. So, now we're going to do Pythagorean Theorem, because we know that if this is a right triangle, then c squared will equal a squared plus b squared. If it is a right triangle, if we want it to be a right triangle, we're going to force c squared to equal a squared plus b squared. That's what will make it a right triangle. So, c squared, a squared plus b squared. Be so careful when you square these. X plus 3 squared is x squared plus 6x plus 9 equals 14 squared. 196. I think I remember that one. Yep. 196 plus x squared plus 2x plus 1. If you don't FOIL, you will forget that middle term. Okay, Johan, take care of that whenever you can. If you don't FOIL, then you will forget your middle term. Okay, this is what we love to happen. I'm going to go, did it? Okay, this is what we love to happen. The x squared terms are going to cancel because we have an x squared on the left and we have an x squared on the right. Those are going to cancel. So let's clean it up. 6x plus 9 equals 197 plus 2x. Let's move things around. 4x equals 188. Hopefully that's divisible by 4. Yes. X equals 47. What do you think, guys? I'll get back to you, Johan, okay? Find the value of x. Okay, we did what we set out to do. Find the value of x that would make this a right triangle. We got that x is 47. If we were taking a quiz or a test, I would plug my answer in and make sure it makes sense. If x is 47, then this side is 48, and this side is 50. Does that fit into Pythagorean Theorem? 14, 48, and 50. Let's see. 14 squared plus 48 squared is 2,500. 50 squared, oh, look at that. It's 2,500. So we got an answer. We checked our answer, so now we can move on. Magic. Okay. Not sure if we checked our homework answers last week. So here's the homework answers. 1 through 22. 1 through 22 was just mixed review. And then 23 through 31 was what we learned last week. 23 through 31 was Pythagorean Theorem converse. So take some time to check your answers and we can go over a couple of these. Something today. Yes. Let's see. Okay, so this is what we learned last week, and you're going to have 2 questions on your quiz about this today. The most of the quiz is Pythagorean Theorem and radicals, but you're going to have 2 questions about acute, obtuse, or right on your quiz today. I was asked about number 25. It's not the toughest one from this section, but I'll do it. You need to first identify which one is C, which one is the largest. The next step that you're going to do is you're going to write Pythagorean Theorem, but you're going to write it backwards. We're writing it backwards for a certain reason, okay? Then we're going to solve it. C squared, and then A squared plus B squared. Then we're going to give it an inequality, a greater than or less than or equal to sign. The sign is going to eat, it's going to open up to the larger number. It's like it's eating the larger number. Then you read the sign. You always read from left to right. This is a less than sign. So since it's a less than sign, our triangle is acute. When it's a greater than sign, our triangle is obtuse. So less than, acute, greater than, obtuse. So that's what makes this one acute. Do you want me to work any others from this section? 14 is from just the mixed review part. Oh, you know what? Today we are going to learn a shortcut to solve this one. I will set this one up for you, but I'm not going to solve it completely because we are going to learn this great shortcut. So technically on this one, you would want to name these a letter, like name it A, A. All the sides are A. So if you're looking at this right triangle, you would do A squared plus A squared equals 11 root 2 squared, okay? Because it's a square and all the sides are the same letter. Don't name one of them X and one of them Y. Name them both the same letter. So this is 2A squared equals, be careful, that's 11 squared times square root 2 squared. Remember, you have to square both terms. Very important. Let's see, what is that? 121 times 2? I guess I am going to solve it because it's not that bad. Well, when you end up dividing both sides by 2, we're kind of introducing today's lesson actually. A squared, we're back to this. A squared is 121. So A is the square root of 121. What's A? 11. It's 11, 11, 11, 11. So now we would look at this triangle right here, and we would do Pythagorean Theorem. 12 squared minus 11 squared equals x squared. So 144 minus 121 is 23. So x is the square root of 23. And that is a really good introduction to today's lesson. Do you want to do any more homework before we go on to today's lesson? 29 is a very important problem that you will see again in the future. This right here says AC is parallel to FG. So we can add arrows to our picture because we know that it's parallel. What we're going to do first is we're going to look at this triangle. And what we're going to do is we are not going to assume it's a right triangle. Is everyone listening? We are not assuming that's a right triangle, even though it surely does look like one. So since the jury is out and we don't know what kind of triangle this is, we're going to use Pythagorean Theorem converse. And we're going to find out what kind of angle angle D is. So we have 625 and we have 612. 625 is greater. C squared is greater. So this angle right here is obtuse. Now it's asking about the measure of angle 1. Is angle 1 acute, obtuse, or right? It's not asking about angle BDC. So now we need to remember what's true about parallel lines. Remember, if this angle is obtuse, let me draw it kind of obtuse. That is corresponding with this angle. That means this one is also obtuse. And then that angle and angle 1 make a linear pair. Well, if I had a linear pair and one of my angles was obtuse, what would the other angle be? It would have to be acute. Another way to look at this, is this angle and this angle are same side exterior angles. Same side starts with an S. That means that angle and angle 1 are supplementary. If two angles are supplementary and one of them is obtuse, well then the other one has to be acute. So the answer to number 29 was acute. Yes, there's a quiz today. So today's entire lesson is focused around right isosceles triangles. What we're going to learn today absolutely will not work if the triangle is not both right and isosceles. Sometimes I like to nickname these isosceles triangles, like a rhinoceros, isosceles, because they have to be both right and isosceles for what we're going to do to work. Isosceles triangles. Did you label a picture? I hope you drew a right triangle, and then I hope you put tick marks on it. Did you go as far as to find the angle measures? Well, we have 180 degrees and we subtract 90. That means we have 90 left. Good. Now we know that these are going to be perfectly congruent because if it's isosceles, then the base angles are congruent. And so these angles must be 45, 45. So today we're going to call these triangles 45, 45, 90 triangles. 45, 45, 90 triangles. So when I say 45, 45, 90, I'm going to expect that you know that I'm talking about the angles of this certain special triangle. If you were to do Pythagorean Theorem with these, you know that this is 5 and 5. We know that this is 3 and 3. We know that this is 1 and 1. This would be x and x. If you were to sit there and do Pythagorean Theorem with all of these, or c squared or whatever, and then you take the square root and then you factor tree it, let's pretend that we did Pythagorean Theorem all 4 times. Let me tell you what you would have gotten for the hypotenuse. On this one, if you factor treat it, you would have gotten that. On this one, once you do Pythagorean Theorem and you factor tree, you get that. On this one, once you do Pythagorean Theorem and you factor tree, you get that. And on this one, once you do Pythagorean Theorem and factor tree, you get that. Do you see a pattern here? Do you see a shortcut that we could take every time we have isosceles triangles? 5, 5, 5 root 2. 3, 3, 3 root 2. Say it with me. 1, 1, 1 root 2. X, X, X root 2. So it is a shortcut that we get to use to solve for missing sides of right isosceles triangles. And yes, you're probably wondering, why are we learning this shortcut? Do these really come up that often? Yes, right isosceles triangles come up a ton in the real world. They're everywhere. So write down this rule in your notes. We'll do a couple practice problems and then you get to go for that quiz. So let's talk about this. If you're missing a hypotenuse and you have a leg, you are in good shape. That is about as easy as it can get. So if you, let me draw it a different way. If you know that that is 3, you now know all of the sides of your triangle with only knowing one side. So you know this is 3, and this is 3 root 2. Now just be careful. If you know a hypotenuse, what if you knew a hypotenuse and you didn't know the legs, and your hypotenuse didn't have a root 2 after it? What would be, when we're trying to find a hypotenuse, we multiply by root 2. What would be the opposite of multiplying by root 2? You already said it. Cool. Dividing by root 2. So if you're ever given a hypotenuse and you need a leg, you divide by root 2. I think I have that on the next slide. Oh, I'm sorry, we might not get to the clip. We might. If you are missing the hypotenuse, you are multiplying by square root 2. If you're missing a leg, you are dividing by square root 2. That was supposed to be a multiply sign. It looks more like an X. Here we go. So when you're going, I think of it when you're going forwards, when you're getting bigger, you multiply by root 2. When you want to go backwards and get smaller, you divide by root 2. Okay, we're going to do practice problems and we're going to go through it quickly. Let me get my cards out. So when you have a problem like this, you're going to look at what you're given. Is it right? Check. Is it isosceles? Check, because it's 45 and 45. So now we know we can use the pattern. 9, 9, 9 root 2. We're done. The problem's over. We are not doing Pythagorean Theorem because we know that this is how it works every time. Next one. The hypotenuse is 2 root 2. So in essence, we are technically going to divide by root 2. You don't have to actually show this work. I just want you to see what's happening. They cancel out. And so it's 2, 2, 2 root 2. k would equal 2. It follows the pattern. 2, 2, 2 root 2. Do not tell me that s is 5 on this one. Let's be careful. We have a leg, so it's going to follow the same pattern. 5 root 2, 5 root 2, 5 root 2 root 2. Now, can we write that as our answer? Is that what s equals, 5 root 2 root 2? No. We know that this would be 5 root 4. This would really be 5 times 2. We know that this would be 10. The square root of 2 times the square root of 2 is 2. So it's really just 5 times 2. So this one doesn't follow the pattern as nicely. 5 root 2, 5 root 2, 10. But technically 10 is 5 root 2 root 2. Simplify. Very good. Yep, we're just simplifying. Okay. Here's where one of the ones where it's going to get a little bit ugly. I gave you the hypotenuse, and it doesn't have a root 2 on it. So you have to pull a root 2 out of it, because the root 2 isn't showing right now. It's there, it's just not showing, right? So I gave you, we know when we go backwards, we have to divide. I gave you a hypotenuse. We're going backwards, so instead of multiplying by root 2, we're going to divide by root 2. Now, we can't put 6 over root 2 as an answer, because we know radicals are not allowed in the denominator. So we are going to have to rationalize. Square root 2 times square root 2 is 4. Nope, no it's not. Hello, it's 2. Square root 2 times square root 2 is 2. 6 times square root 2 is 6 root 2. So the final answer to this problem is... And you can always check your answer. You can do the chant. 3 root 2, 3 root 2, 3 root 2 root 2. Is 3 root 2 root 2 6? Well, 3 root 2 root 2 is 3 times 2. So yeah, it is 6. So that means we did the problem right. The answer is 3 root 2. Okay, I'm going to go over these quickly. When I rotate the triangle on you, don't get confused. We have leg, leg, hypotenuse. So it's going to be 2 root 3, 2 root 3, 2 root 3 root 2. And then you just simplify it. What is 2 root 3 root 2? Well, you're allowed to multiply those. Radicand, radicand. So it is simply 2 root 6, and you're done with that one. 2 root 6. Okay, the last problem of the day. Find the value of p. Now, be careful. 5 root 6, that's the hypotenuse. We know when we're going from a hypotenuse to a leg, we have to divide by root 2. When you're going forward, you multiply. When you're going backwards, you divide. The good news is, guys, look, 6 is divisible by 2. Do not rationalize the denominator. Don't do it. These are divisible. This is like saying 5 times, oops, that's not a 3, it's a 2. It's like saying 5 times 6 divided by 2 because you're allowed to do that. So the answer to this one is just, oops, 5 root 3. 6 divided by 2 is 3. So this is just 5 root 3. Okay.